Hey kiddos, here's the spiral review for spiral 22. We're going to start off with logs, particular intro and graph stuff. First thing, we've got a log graph that's given to us, and I'm asked for a transformation. Here you've got a horizontal flip, and it's going to go up 1. So let's kind of do both of those at the same time. I'm so glad I put this graph here in this location because we can't really see the left side, but 1, 0 is going to flip across to negative 1, 0 and go up 1. 4, 1 would flip across to negative 4, 1 and then go up 1. That'd be a negative 4, 2. My asymptote is going to flip, but that's already at the y-axis, so we're just going to do this. For number 2, we've got 2 times the 3 to the x minus 3 minus 5. I'm just going to kind of briefly summarize this. We got a horizontal asymptote at negative 5. And then I'm going to make a table. I like choosing numbers that make the top easy, so I'm going to choose 3 and 4. That gives me 2 times 1 is 2, minus 5 is negative 3. And then we're going to have 2 times 3 is 6, minus 5 is 1. So 3, negative 5, that's going to be... sorry, that can't be right. It should be negative 3. I just can't read my own handwriting. So plotting those points, we got 3, negative 3, and 4, 1. That's totally not 3. I'm doing awesome today. It's going to look like this, but actually hitting those points. Moving onward, we've got a table, and this is the table of y equals 3 to the x. The goal here is to understand that logs and exponents are inverses, so that we're switching the x and y coordinates. 1 over 243, comma, negative 5 would be our first point. Second point would be 27, comma, 3. And our third point would be 81, comma, 4. For number 4, we are converting these to exponential or logarithm. This is based on the relationship between logs and exponentials. So we've got base, argument, and exponent. This becomes c to the g is equal to b. For number 5, we have a trick. We set this equal to e for exponent. And same thing we just did. So b, a, e. 3 to the e is equal to 1 over 81. Since 3 to the 4 is 81, 3 to the negative 4 would be 1 over 81. And that's it on this page. Next up, we got some log properties. We got to do some condensing. And I'm going to start with my powers. So we're looking at log of x to the 3 plus log of y to the 1/3. Now if I'm adding, I'm going to multiply on the inside. So this is going to be log of x to the 3, y to the 1/3. Or if you want to be really sneaky, you could write this as log of x cubed and the cube root of y, because the 1/3 power is the same as the cube root. Number 7, we're going to do some expanding the opposite way. Hey, look, we've got a square root here. We're going to use the same thing we did last time. I'm going to start by separating these because they're all multiplied. And that's going to be log base 2 of 3 plus log base 2 of x squared plus log base 2. And I'm going to write this as y to the 1/2 instead of square root of y. So that's going to be log base 2 of 3 plus exponent comes down 2 log base 2 of x, and the exponent comes down, plus 1/2 log base 2 of y. Alright, we're going to solve this using exponent rules. I noticed that everything here is connected to 9. I can't get to 27 from power of 9, so let me try 3. So we got 3 to the 1 is 3. 3 to the 2 is going to be 9. 3 to the 3 is 27. 3 to the 4 is 81. Okay, that's a winner. But we want 1 over 81, so it's going to be 3 to the negative 4 is 1 over 81. Okay. So we're going to have 3 squared to the 3x minus 5. That's going to give me 6x minus 10. And then we're going to have 3 to the 4th to the x plus 1. So that's going to give me 4x plus 4. And that's equal to 3 to the 3rd. So that's equal to 3. 6x plus 4x is going to be 10x. Minus 10 plus 4 is minus 6. If that equals 3, then we're going to bring the 6 over. So we get 10x is equal to 9. X is equal to 9/10. Number 9, we're doing some more solving. This time we got to get the exponential part by itself. Minus 8 to both sides divided by 2. We get 3 to the x minus 1 is equal to 5. Now I'm going to convert this to log. Log base 3 of 5 is equal to x minus 1. Finally, we're going to add 1 to both sides. So log base 3 of 5. I'm going to put the 1 plus in front so I don't accidentally add it. And that's equal to x. The next one is the same thing but going the opposite way. We got to get this log by itself, so I'm going to add 4 to both sides. That's 6. Divide both sides by 3, and that gives us 2. So log base 5 of x minus 3 is equal to 2. I'm going to convert this, and that becomes 5 squared is equal to x minus 3. That means that x is going to be 28. And that's it for this page. Next up, we got exponential models. I don't have a calculator here, so I'm just going to be able to kind of guide you through the calculations. So the first one, we're asked to interpret each of these pieces. G of t is going to be the sequences available. $6.7, that's our starting amount. $1.45 is going to be 45% growth. And T is going to be years since 2002. If you were to plug 17 in for T, that means 2019 and how many available sequences. I can't write today. Alright, number 11, nothing there. Number 12, we got a red hot sword being plunged into cold water. And we got to write some kind of an equation for this. Alright, so we got a starting value. So A is equal to 256. Every 9.7 seconds, that sounds like a K value to me. And is reduced to 1/4 of its temperature. That's going to be kind of weird. That's going to be 1/4 in there. So that we've got T divided by 9.7. How hot was the sword 20 minutes after leaving the fire? Oh boy, 20 minutes is 9.7 seconds. Yowzas. This is going to be pretty small. I kind of wish I had a calculator right now, but I don't, so I'm sorry. So we got 1/4, 20 minutes. This is seconds, so 20 minutes times 60 seconds is going to be 1,200 seconds. So we're talking about 1,200 divided by 9.7. Alright, how long would it take the sword to come down to room temperature? So it's saying 23 is equal to 256 times 1/4 to the T over 9.7. This is going to get real ugly real fast. 23 over 256 is equal to 1/4 to the t over 9.7. I have no way to deal with this except to convert this into log. It's going to be log base 1/4 of 23 over 256. And that's going to be equal to t over 9.7. We're going to multiply both sides by 9.7. And that's our final answer. 9.7 log of 1/4, 23 over 256. And finally we get the new stuff, right triangle trig. Solving for BC. So we're given angle A. And we've got the hypotenuse. We want the opposite, that's sine. So I'm going to zoom in so I can actually write legibly. So we've got sine 65 is equal to question mark over 6. Multiply by 6, our final answer is 6 sine of 65. For number 14, we got to find sine of B. Now we've got a new opposite, new hypotenuse. So that's going to be, we got to figure out what that is. I'm just going to call this smiley face for now. You could figure out what that is with the Pythagorean theorem. I don't have a calculator on hand, so I'm not going to actually get the calculation out. Sorry for the yawn there. So we've got smiley face over 6, tangent of B, opposite over adjacent. Well, I guess we kind of have that. Smiley face over 6 sine of 65, and cotangent of A, adjacent over opposite of from A. So we're looking at smiley face over that same thing. So that's cotangent and tangent. Alright, and then we do the Bugs Bunny one. 33 meters below ground, that gives us a nice picture. And we're looking at what happens when he wants to be above ground. And what we're really looking for here is this angle of elevation. Okay, we've got the opposite, the hypotenuse. This is a sine problem. So I'm going to start off with sine of the angle is equal to 33 over 80. To get the angle, we're going to do sine inverse of 33 over 80, and that's going to be equal to that angle. At that point, we're done, or you can solve this out using a calculator.